Good day, grade 9. So let's have the continuation of our lesson last meeting. The title is all about illustrating and translating variations, MELC number 17 and number 18. It illustrates situations that involve the following variations: direct, inverse, joint, and combined variation. We also need to translate into variation statement a relationship between two quantities given by a table of values, a mathematical equation, graph, and vice versa. So let's have a short recap of what we have learned last meeting, which is all about the definition and some situations regarding direct and inverse variation. If we say direct variation, as discussed last meeting, it is a relationship between two quantities in which an increase in one quantity produces an increase in another quantity, and that their ratio remains the same. If y, so we have here a statement, and later on we will convert this one into a mathematical equation. If y varies directly as x, then y is equal to constant times x, or k is equal to y divided by x, where k is the constant of variation. This proportion can be applied to direct variation. Y sub 1 divided by x sub 1 is equal to y sub 2 divided by x sub 2. An inverse variation is a relationship between two quantities in which an increase in one quantity produces a decrease in another quantity, and that their product remains constant. Statement: y varies inversely as x. Then y is equal to k divided by x, or k is equal to x times 1 y, where k is the constant of variation. This proportion can be applied to inverse variation. You are multiplying the two variable. Y sub 1 multiply it by y sub 2 is equal to x sub 2 multiply it by y sub 2, or x sub 2 divided by y sub 1 divided by x sub 2 is equal to y sub 2 divided by x sub 1. We also have here to check if the table of values represent a direct or an inverse variation. It follows the different steps. First, you need to check the trend of the values x and y. If the values of x and y have the same trend, same. Example, as the value of x increase, the value of y also increase. And as the values of x decrease, the values of y also decrease. Then the table represent a direct variation. If the values of x and y go on opposite trends, for example, as the values of x increase, the values of y decrease, and vice versa, then the table represents an inverse variation. If we graph the two variation, direct variation is a straight line. Inverse variation, the other one is increasing and the other one decrease. So this one is not a straight line. Number 2, determine if there is a constant of variation. A direct variation follows the formula k is equal to y divided by x to solve for the constant of variation, while an inverse variation follows the formula k is equal to xy to solve for the constant of variation. And now let's proceed to the third one, which is all about the joint variation. If we say joint variation, it is a direct variation, but with two or more variables. So, for example, y varies jointly as x and z, or y is equal to k times x times z, or k is equal to y divided by x times z. You are just finding for the constant value. So, we have here the different examples on what joint variation is. Number one, the amount of interest varies directly to two variables, P, which is the principal, and T for the time. The constant is R, rate of interest. So if we convert this one into a mathematical equation, amount of interest, that is I, is equal to P, which is principal, rate, which is R, T, which is the time. So, interest is equal to P, principal, times rate times time. Number two, the volume of a box varies directly to three variables, length, width, and height. So, if we convert this given statement or this given mathematical statement into a mathematical equation, this one is V is equal to length times width times height. Number three, the cost of operating appliance varies as the number of watts drawn, hours of operation, and the cost per kilowatt hour. So this one is also an example of a joint variation. Number four, the volume of a sphere to its radius and height. And the last one, area of rectangle with its length and width. This one is also an example of a joint variation because it shows two or more variables, or it involves two or more variable. Then let's proceed to combined variation. Actually, if you already know the difference between direct, inverse, and joint variation, you can now easily combine, or you can now easily compute for the combined variation. So let's proceed, or let's define first what combined variation is. It describes a situation where a variable depends on two or more other variables. It forms when we combine any of the variation together, direct, inverse, and joint. So here is an example of a mathematical statement, and then we will convert it into a mathematical equation. Y varies directly as x and inversely as z. So if we convert this given statement into mathematical equation, this will become y is equal to k times x inversely divided by z. Let's have here another example. The speed r of the car to the distance d traveled and time of travel. So this one is an example of a combined variation. In mathematical symbol, r, which is the speed of the car, is directly proportional to the distance and inversely proportional to the time of travel. Since the speed varies directly to the distance and inversely to the time, it is an example of a combined variation. Number three, the kinetic energy of a moving object to the mass of the object, and inversely the square of the velocity. So this one is also an example of a combined variation. Number four, if x is directly proportional to y and inversely proportional to z, what happens to x if z is threefold? So first, we need to look the equation behind this given statement. If x is directly proportional to y, so x is equal to k times y, and inversely proportional to z divided by z. What happened now to x if z is threefold? So let's substitute. If z is threefold, So, x now, the formula will be x is equal to k, constant, times y divided by 3 times z. The value of x become 1/3 of the original value, or it decreased by 67%. That's all. Good day and thank you.